We are back here at the EarthX TV podcast stage here at the wonderful Hilton Anatole. EarthX 2026, just a bunch of heroes, people who are making a difference, people who are actually out there in the field doing the work of making this planet a more sustainable place. And I got some folks next to me today who are really doing some amazing things and tackling like a source of pollution and carbon footprint that we generally don't think about. And it's about like literally air conditioners and the things that are emitted from them. And they are attacking it from different angles. So I've got Kristen Sissner and Andrew Blair right here with me. And I'm going to start with you, Kristen. Ladies first. You got Berkeley Earth. And as I understand it, and maybe you could break this down, you guys take these large data models that are complex and really heady for folks, and you simplify them. Tell me about the work that Berkeley Earth does.
Absolutely, we'd be really happy to. And thank you, Theo, for having us here, and thank you to EarthX as well for having us. It's great to be here to talk about Berkeley Earth and some of the work we're doing. And so just a really quick introduction to Berkeley Earth. So we are an NGO that's based in California. And what we've been doing is we've spent the last 15 years developing one of the largest and most comprehensive observational temperature data sets in the world. And so we have over 1 billion observations and 250 years of really detailed temperature history.
250 years?
250 years, going back
What?
250 years in temperature observations. And something that's really unique and special about Berkeley Earth is that we are the only organization globally doing this work that's not a government, that's not affiliated with a university, and we don't really have a stake in any one particular outcome. We really just want to work with the data and produce the best data possible. And so what we've been working on recently as an extension of that is taking what you mentioned, these global climate models, which are huge. They're just, I mean, data-wise, they're just huge. And they're very difficult to work with. And we've been using this observational product that we have and using it to make climate models easier to work with, more accessible, and more relevant for local decision makers.
Got you.
Yeah.
That's awesome. And so, Andrew, you're with a company called Helix Earth, and I heard that you guys might have some connections with things that are going into outer space. I'm not going to tell you these folks too much about that, but tell us about the work of Helix Earth. What are you guys doing?
Yeah, absolutely. We certainly do have a NASA space connection. So Helix Earth was born when one of our co-founders, Rawan, was working at NASA as a test engineer, and they were designing fire suppression systems for the Orion spacecraft for the mission to Mars.
Right.
And while they were doing that, they had difficulty designing a filter that would help them separate out liquids from the airstream. They would kill the fire, they'd use liquids to kill it, and then they'd have to filter everything that they used to kill the fire out of the airstream. And they needed something that would separate out the liquids, or else they wouldn't be able to filter out the solids afterwards. And so they tested everything that was on the market and found nothing was able to work for them. And so they ended up inventing a filter with a helical pattern inside of it that acts like a centrifuge and spins out the water out of the airstream.
Wow.
And so they did that successfully for the Orion spacecraft. And when our co-founder Rawan left NASA to do his PhD at Rice University in Houston, they said, "We'll fund your PhD and we'll work with you to get the patent for this on Earth, as long as you can figure out some productive way of using it on Earth." And when you fast forward a couple years later, he graduated and founded Helix Earth. And the first place that we're applying that technology is to do very efficient dehumidification and air conditioning. So dropping air conditioning emissions by almost half for commercial buildings.
That's amazing. So let me ask you, because when we think about emissions and the carbon footprint left behind by like human-made technology, we have to think about cars and trucks, planes, trains, automobiles. But tell me what the footprint of air conditioners does when it comes to our contribution to climate change.
Yeah, it's a great question, and it's a very important question for us, because this is an area, like you mentioned, that is relatively underappreciated as far as emissions go. But it's becoming an ever more important part of those emissions, because people's desire for air conditioning is going up. Both people are in countries that never had access to air conditioning are getting it for the first time, but also people, because the planet is warming, want it more.
Of course.
And I think of my cousin lives in Paris, and when she moved there about 10 years ago, no one had air conditioning, and they had incredible heat waves over the last few years, and everyone's getting it, right? And so that's a problem, because as people want it more, it's becoming a greater share of global emissions. So by 2050, it's going to be about 8% of global CO2 emissions. And how do you both give people these comforts that they want and need while also reducing the net footprint for these things. It's very difficult.
I bet it is. I remember I literally just came back from Africa, and I experienced heat there that made me be like, if the air conditioning dies, so will I. I mean, it was intense, right? And I was so grateful for these things. And of course, the smaller models, the units, they just run off of whatever is most readily available.
Diesel.
You know what I mean? And so you got a situation where the need is increasing, and now companies like Berkeley Earth are able to measure it better. What do you see as the solution to this rising need for air conditioning as the heat of the planet rises as well?
Yeah, that's a great question. And I think one of the steps before the solution, and it's one of the really exciting things that we've been able to do with this new data that we're working with these downscaled climate models, is able to actually quantify what the demand is going to be. And so once we produced these new downscaled climate models, we're calling it synthesis, we took the synthesis data and we partnered with a large organization called C40 Cities. They're
Say that again?
C40 Cities.
C40 Cities, all right.
Cities. They're a global network of mayors from 100 of the world's largest cities, representing close to 25% of global GDP. And they came to us and they said, we need data because we want to better understand what the demand for energy is going to look like, because the global air conditioning demand is also going to increase because of heat. And so they were able to use our data in a model that was able to show globally at the city level, not just saying, a general large figure for the whole planet, but at the city level, what that increased energy demand is actually going to look like. And so you mentioned being in Africa and the significant heat there. Some of the largest increases in demand for air conditioning is going to happen on the African continent. You also mentioned Paris. A lot of Western and Northern Europe doesn't have air conditioning already. They didn't have a climate in the past that really warranted a lot of air conditioning. And that's going to change. So, I think then we talk about moving into solutions. I think understanding exactly what you're going to need in terms of infrastructure build out to get to meet that demand is really how we start talking about solutions, and then companies like Helix Earth come in.
Absolutely. So tell me, Andrew, when it comes to like this Helix technology that disperses the water and makes sure that like things cool down in a different way, is that scalable? Like, could I get like a Helix technology air conditioner to put in like a unit somewhere in like Accra? You know what I mean? Like, what are the horizons for you all in making this more readily available?
Yeah, absolutely. Actually, a large part of what we're doing is specifically geared towards making the sorts of technologies that we are seeing and we're developing more readily available, more broadly. And part of the reason that we're targeting that specifically is because of the technology that we've fundamentally invented and are working with. So this filtration that I mentioned, this helical pattern, what it allows us to do is take what is called desiccant-based dehumidification, which is basically a liquid salt that helps chemically dehumidify more efficiently than a regular air conditioning can, and shrink it into a package that's far smaller and can be applied more broadly than would otherwise be the case. So the type of air conditioning that we're talking about has historically really been only used in industrial air conditioning, which means that you have a big building that's very expensive, that someone's willing to pay a lot of money for. Well, then you can get this really efficient solution. But that obviously doesn't work in the broadest part of the market for the broadest number of people. And so for us, this has been a real calling card for what we're doing, because it's enabling these sorts of solutions to reach the entirety of the market, not just parts where people have the spare capital to afford the heavy, very expensive piece.
Got you. So I'm wondering, when it comes to like the energy consumption of these new units, are you aware of like the difference between what they consume versus what is standard on the market right now? Yeah,
absolutely. So this is a huge part of the problem for air conditioning, and it's on its face, somewhat simple one, which is that air conditioning, conventional air conditioning, is ubiquitous everywhere.
Yeah.
When you talk about a window AC or something like this, like that's regular direct expansion air conditioning.
Of course.
But it's very efficient at doing what's called sensible load reduction. So basically dropping the temperature down in a space. But it's very inefficient relatively at doing dehumidification or latent load reduction. So removing water from the air, dropping the humidity, making it less sticky in the air. And so what we're doing is specifically solving that problem. And the reason we're solving it is because the humidity load can be up to 80% of the energy consumption of a regular air conditioner.
Wow.
And so if we can take that piece and do that far more efficiently, we're able to make a big difference for these sorts of buildings. And so that's really the key driver of difference for us. So you take, as an example, a building that, it's set at 68 degrees Fahrenheit, and it's overcooled. It's, you're wearing a sweater even though it's 90 degrees outside.
Right.
Have you ever had that happen?
Oh yeah, like yesterday.
Yeah, exactly. And the thing is that you typically have that because you don't have direct humidity control, and you can't make it more dry without overcooling the space. And so what we're able to do is decouple the latent and sensible load and allow you to set the temperature higher, make it drier in the building, but get the same net cooling effect because people feel better in the building. And that difference, that 6 degree delta in Fahrenheit temperature, can be almost half of the energy consumption of an AC. I mean, literally dropping it by almost 45%, which is remarkable, but true.
I get excited when I hear about solutions like this because it's like, oh my God, there's a way through the doom and gloom, right? And I'm wondering, is there a way that your two companies are possibly going to be working together when it comes to like your scale up and the data that you collect? Is there like a bridge between these two?
I mean, I think there definitely is a bridge, and I think, some of the partners that we're really looking to work with are any decision makers out there that are really thinking long term about these build outs, because Andrew's product, their incredible product, is really just one piece of a larger puzzle, which involves generating the electricity, even if it's a lower, if it's a significantly reduced energy profile than traditional air conditioning technology. There's still a tremendous amount of energy infrastructure that's going to need to be built. We're talking a lot about energy build out, with data centers and other really high impact, high energy consumption technologies right now. So, something that we're really able to model is what long-term demand is going to look like. And, that's one piece. And then absolutely, Andrew's company can come in and say, we can also, provide now the solution that can reduce that energy consumption. So we're thinking long-term. We want to model at scales that you haven't necessarily had the technology and the data to be able to model at so far. And absolutely.
Yeah,
Absolutely.
totally. I mean, for us at Helix Earth, it's a really clear point in which we can work together and use the data that you all are providing. I mean, for us, we're at an early stage. We're looking at pilots and commercialization and production and all these things. And every single time we go to a customer and we tell them we have this incredible thing, all the benefits that I mentioned here, the first thing they say is, show me the data. And, they mean...
And we got data right here.
Exactly.
We have a lot of
exactly.
data.
And they want data from us, right? They want to make sure our unit works and does all these things, but they also want to say, well, where's the real benefit? Why are we doing all of this? And so the data that Berkeley Earth and C40 Sitters are able to provide for us is really a big deal, because we can say and point to that very specifically and very fine-tuned in a way that's directly specific to these people, how it makes a difference.
Wow. So what do you think your time horizon is from like where you are right now to like mass production, where the fact that like I can get one and the folks, in like Nigeria can get one and people in Paris can get one? What do you think that time window looks like for you?
Yeah, we're based in Houston, Texas. So right now we're in this very exciting time where we're looking at commercial pilots over the course of the summer and into the fall, and looking at scaling production in the early middle of next year. And so it won't be that long. I mean, the company's been in business for about 3 years. Of course, the technology long predates us with our NASA heritage, but we've come a very long way in a short period of time, and we're looking, very promising. We just raised a significantly oversubscribed Seed Plus round of about $12 million, and we're very excited about that, and that will help us propel our next phase of growth as we start to reach the market as well.
Got you. And so, Kristen, what I'm thinking about is like, who would be your ideal partner when it comes to like expanding in your next phase of development? Like, what is it that you would need right now to make sure that this information got out there in a way that would be impactful?
Yeah. So again, we're very early in our product rollout as well. We're looking for partners, who want to use this data in their own modeling. Partners, like C40 Cities, who are running kind of their own projects. We really want to find applications where it's useful, and then from there, we have this technology, we have kind of the math and all the algorithms sorted out. We can start applying that to other variables. So we're working in heat right now, but we can start talking about water, precipitation.
Wow.
So a lot of the other climate and weather variables that are really going to impact our energy demand over the next 10, 20, 30, 50 years.
Amazing. The work that you guys are doing is something that I feel is really important to making sure that we can quantify if there is change.
Correct.
You know what I mean? And give folks tangible examples of where they can actually make a difference. Because if I, as a consumer, have the option to either purchase something that pollutes more or pollutes less, I'm going to choose the one that pollutes less if it's cost effective. So, I know that that's another thing, but I really feel like there's a lot to be gained by what you all are contributing. I wanted to know real quick, when it comes to like the next Artemis mission, what are the odds that you guys are going to have the ability to have your technology and product on that?
So we are very excited at the prospect of our tech being in space as it was designed to be, and it looks likely that it'll be applied, in the near future. I know specifics there, given that it's all soon to come, but we're very excited about where it all goes.
Hey, just as an 80s kid, I'm glad the space program's back up and running. I'll tell you what, you know what I mean? Because it's something that always kind of gave us hope. And like a lot of younger generation doesn't understand, like when you were in the 80s, it felt like the sky was the limit, like anything could happen, that's what they told us in school. And when the space program got shut down, I was like, oh, and that was coming back and you're a part of it. I think it's just like really, really cool, bro.
Yeah,
absolutely.
We're very excited. It's very much a feather in our caps that, as we're going through this process of launching our company, that there's a launch going on at NASA as well. It's great stuff.
All right. Listen, man, y'all have been great. Kristen, Andrew, you're our climate heroes. Before we wrap up, can you tell us where we can find you online?
BerkeleyEarth.org.
BerkeleyEarth.org. And you, sir?
Yep, HelixEarth.com, and anything Helix Earth, you can find us on LinkedIn and otherwise as well.
Absolutely. Well, thank you very much for contributing to us. This is EarthX 2026 here at the wonderful, beautiful Hilton Anatole, Dallas, Texas. And at the EarthX TV stage, you're going to get a lot of folks who are doing a lot of good work. It's the podcast stage specifically, and we'll be right back. Thank you.